Welcome back on this beautiful Friday, wherever you are. We have a great episode for you today, very timely as we're past the midpoint of October. And I don't know about you guys, but where I am, it's starting to get darker. Although it's been shockingly warm lately, we're heading into the winter. And so supporting immune system is going to be all that we're going to talk about for a little while. This episode covers incredible research on a compound that supports the immune system in very surprising ways. So you're in for a treat. So before we go there, I want to thank you guys for being here as always. And I would love to encourage you to go to natnidham.com and sign up for my newsletter there, because that's where I get to communicate with you guys. We give you a little overview of the podcast episodes every week. We also talk about some of my favorite biohacks that I come across and why they're amazing. And that way you can choose what's right for you. And of course, we have every once in a while, we talk about special events, summits, all kinds of stuff. So it's a really nice way for us to keep in touch. So that's natnidham.com. And at the top of the page, there's a red bar. You can sign up for the newsletter. And these days, you'll also get an 8-part series, which is it started off almost like a little mini book, and we basically broke it up into 8 emails to talk about all the different lifestyle strategies, all this free stuff that you can really do to up your health game. And the culmination, the end of it, closes with the bioregulator peptide table, which basically breaks down different bioregulator names, what they do, the whole 9 yards. So it's pretty cool. I'm pretty proud of it, and I've gotten some great feedback on it. What are we doing to protect our immune system as we age? Good question, right? So in this longevity podcast episode, I am joined by Dr. Anurag Singh to discuss recent research that suggests that Urolithin A, a compound derived from pomegranates and other foods, actually a postbiotic, may actually help rejuvenate the aging immune system. We dive into a 4-week study that showed shocking results in biological age for the participants. And this is a human study. We also discuss insights on dosing, combining Urolithin A with other longevity strategies, as well as ongoing clinical trials that may reveal even more benefits as we move forward. Now, Dr. Anurag Singh is the Chief Medical Officer of Timeline Nutrition, which is a biotech company focused on discovering and developing next-generation natural compounds that target improvements in mitochondrial health. So if you want to get your hands on Urolithin A, if you're not taking it yet, after this episode, if you're convinced and you're like, okay, I got to get my hands on this stuff, you want to go to timelinenutrition.com/NAT10 and use code NAT10 to save 10%. Now let's jump into the episode. Hey folks, just a quick reminder that all of the information presented in this podcast is for information purposes only. No medical advice, no diagnosing, no treatments suggested here. Before you try anything that you hear about or learn about here, make sure that you check with your medical provider. Dr. Singh, welcome to the show. It is so great to have you back.
Yeah, pleasure as always, Nat. It's lovely being with your podcast again. Talk about our new work.
I know. I'm so excited. I remember when we said we were going to do another podcast, I'm like, so by any chance, is there any new research? And I got hit with this barrage, which we kind of knew from our last episode, right? The last time we recorded was the first time you kind of really started alluding to, which makes total sense. I mean, if Urolithin A impacts mitochondria systemically, then it's going to have a massive impact on pretty much every major system of the body, right? Yeah. And so what we're going to dive into today is immune aging, inflammaging, those hallmarks of aging that are affected by the immune system. We're going to talk about where Urolithin A kind of fits into that. So I'm going to kind of, and I mean, you sent me a couple of really fascinating studies. But before we get into those, let's just talk a little bit about let's talk about the immune system and its role in aging, longevity, health span, because, I will often say things like, the thing that's ultimately going to get you at the end of the day is your immune system. It's going to go up, it's going to probably go down. And typically that's where people lose it.
Right. So, for long in the longevity field, we've talked about these hallmarks of aging that link to telomere changes or telomere attrition. The cellular organelles don't talk to each other. You get a lot of poor nutrients absorption in your cells. Mitochondria is a very key element. We've talked about mitochondrial dysfunction at large. Things like disabled microautophagy, like autophagy and mitophagy is another one. But for long, sort of chronic inflammation has been in the background. This idea that as we age, our bodies get increasingly inflamed, and this is a term we call inflammaging now. And,
Mhm.
and it turns out that that's actually the starting point, for a lot of chronic conditions 20, 30 years down the road. So something after 40s, if our bodies are getting inflamed with stress or with, environmental insults like bacterial, viral infections, and we've all come through this COVID crisis in the last 4 or 5 years where we know what all sequelae, people are facing, like fatigue and so there are these things. So we have focused a lot on these other hallmarks and ignored this inflammaging. And so we had done these trials in the past where we had hints of effects on the immune system, and we just said, let's do a proper study to characterize this effect of urolithin A on immune aging.
Yeah, no, which I think is fantastic. And so, but before we get to the study, let's kind of lay the groundwork for people, because I think that it's, we're going to be talking about CD8 cells. We're going to be talking about T cells
Yeah.
and what the role is really. And I think, what I think is important for us all to get our heads around, and you alluded to this is a process that starts long before we see it come to roost,
Yeah.
right? Like inflammaging is a progressive situation that evolves, probably starts as early as the 30s for some people, but definitely by the time you hit your 40s, things are moving, right? And generally they can be moving in the wrong direction. So the good news is that the earlier you get on it, the less kind of entrench it can get into the system, because not that you can't address chronic inflammation or inflammaging in your 60s or your 70s or your 80s. It's just that by then you're trying to make up for lost ground. And it's always easier, I think, to try and dampen something like this earlier in the game than it is to reclaim. But let's talk a little bit about, this whole idea of how the body is like how the immune system is surveying. Like people talk about often, oh, you have cancer cells in your body all the time, but your immune system gets on it and clears them, and how that sort of starts to shift.
Yeah, so I'm a trained immunologist in addition to being a medical doctor.
How convenient.
So for long, whenever you're seeing these folks, in their 60s, 70s, 80s, sort of the geriatric population, 65 plus, you realize that you're treating the symptomatology, but when you look at biomarkers, like, much like how you would look at heart diseases for cholesterol and LDL, or you look at renal function with serum creatinine, one of the things you will always pick up in these folks who have chronic insult or chronic conditions is very high inflammation. So C-reactive protein, for example, this is a biomarker clinicians use to look at how much inflammation you have and how much of that inflammation is causing an effect on, heart diseases or poor renal function. And so what in immune aging, the concept is maybe three key hallmarks of immune aging. Okay. One is what we as immunologists call immune exhaustion. So this is something that starts in our 20s, 30s, 40s. There's a gland called the thymus that is basically where right here, that's where all amazingly, our immune system education is in there. And because any cell that is educated to fight bacteria, viruses, or cancer, as you were saying, these are coming out from the thymus, and they're called T cells because they're coming from the thymus, right? And they're educated. Now, the immune system is like an army, okay? So you have your T cells, you have your B cells, you have all these vast network of immune system that are patrolling. They're patrolling your skin, they're patrolling your gut lining, they're patrolling your lungs. So wherever we're going to be exposed to viruses, bacteria through the environment. And within this army, there's a special elite forces that I call the T cells. Okay,
Yeah.
These are really the if you don't have CD8 T cells, you will get always an infection. You will have a very high susceptibility to cancer. So this problem with immune aging starts in the 30s and 40s. So the thymus is becoming smaller and smaller, and these very super elite immune cells, like the elite forces, the CD8 T cells, they're becoming very exhausted. And so if they see the same virus or the bacteria, they can't really mount a proper immune response. So that's one thing that we have labeled as sort of immunosenescence or immune fatigue. And then the
Right.
second hallmark is inflammation that we talked about, that the body is getting more and more stressed, whether you get a metabolic health problem like prediabetes or hypertension or mitochondrial dysfunction, they're all causing inflammation or this thing of chronic inflammation. And the third is really the problem is at the immune cell level is they have mitochondria, much like other cells. You were mentioning about the systemic effects of a lot of these nutrients that nobody looks at. The number of healthy mitochondria in these sort of super elite forces declines. And so they don't have the energy to mount the proper immune response. So that's what we are talking in a broad framework.
Yeah, so it's kind of a global issue, as it were, and it brings it back to the mitochondria, right? So I think that it's important to understand that when the body's given a signal to turn over mitochondria, renew mitochondria, and through this act of mitophagy, where there's a self-feeding of damaged mitochondria or mitochondria that are maybe not doing their job properly, that instantly kind of drives the body to produce new mitochondria.
Yeah.
Right.
Yeah.
So this really ties it back, because we talk about urolithin A and mitochondria all the time.
Mhm.
And I think it's really important to understand this isn't some amorphous connection to the immune system. This is a very direct connection to this elite army of T cells that we rely on to do the work for us, right?
Yeah, absolutely. I mean, when we started out, we, of course, when thinking about muscle health, because, the muscle cell has the highest density of mitochondria. And so we thought about, let's look at the muscle, because that's where, you have problems moving as you age or getting up from a chair. And we saw the effects, as we're talking about this improved recycling of bad mitochondria into new. And whenever we would run these trials, we would see the effect on the immune system that we thought was a side sort of benefit, but we never really explored it in great detail. And then it clicked about a couple of years back. One of our collaborators actually ran this study in an animal model where you actually these models have no immune system. Much like how a cancer patient after getting
Right.
chemoradiotherapy
Get wiped out.
will have no proper immune system. And what he found that giving these rodents who had recovered from cancer, but if you gave urolithin A mitopure to these models, the stemness, the rejuvenation effect on the immune system was immense. So when I saw this data, I said, well, we have to run a randomized clinical trial to see what is the global effect on the immune system.
Yeah, that's fascinating. And so when you said earlier that as the thymus gland involutes as we age, so it basically turns to fat. It becomes dysfunction. It stops functioning.
Yeah.
Really. So is it basically that your T cell population is established, and now what we're trying to do is keep this army going, healthy and happening for as long as possible, because you're just not going to be able to regenerate new T cells.
Yeah.
Is
So
that the idea, kind of?
yeah. So there's you have these very young stem cell like T cells, CD8 T cells that are when they're in their 20s and 30s, they're outnumbering what on the other we call is the educated T cells, what we call memory T cells.
Oh, so like the naive T cell versus
That's
the
the
memory.
naive cells, which are young, youthful, stem cell-like, versus the memory T cells that remember. They remember the virus, they remember the cancer, and they are the ones patrolling. And as we age, suddenly we are left with these goodies that are well-educated, but if these viruses and bacteria are very smart, they just change a little structure on their envelope. That's why we all need to, the flu shot we get every year is useless the next year, because you've educated an army of.
We use the year of, but we won't get into that.
Yeah. So that's what leads to immune exhaustion, because now you've educated too many cells that are immune cells that are useless, basically. And so if you could drive more youthful stem cell like naive T cells in your body, and there are people, there are companies that are trying to re-educate the thymus to be a bit more youthful. There are folks who are trying to reseed the thymus, through regenerative ways. But if you could have a natural compound that actually can re-energize these naive T cells into better, more potent, then you have really a chance of improving immune health with aging. And that's what we are seeing.
That's great. Yeah, I mean, definitely in the bioregulator peptide world, we talk about the thymus bioregulator helping to, but it's not a perfect science. Like, it's not magically going to turn your thymus gland back to where it was when you were 20 years old. So can we talk a little bit about Urolithin A, though? Because let people who didn't catch the first one or two episodes that we've recorded together, I often get this comment from people saying, well, can't we just get Urolithin A from our food? And you used to do a really cool thing as a company. When you first launch, you had a kit that you would send people, and it had a bottle of pomegranate juice, and it had these two tests, and you would basically run a test to see how much Urolithin A you were producing. Then you'd have your pomegranate juice. Then you would measure your Urolithin A on the other side. And lo and behold, 70% of people just didn't see that bump. So maybe let's just talk about why I'm talking about pomegranate juice.
No, great. Urolithin A. So what is it? It's a postbiotic, which means it's something made by the gut microbiome, which, by the way, also changes drastically with human aging. So a lot of folks cannot make this molecule, and the reason they cannot make this molecule naturally is because they don't have the right gut microbiome. Now, how do you get it from the diet? You get it from the diet if you're eating a lot of pomegranates, not the shiny red part, but the boring white part.
The white bitter, like the pith.
The bitter. All the good stuff is in the bitter part.
All the good stuff is in the bitter. Yeah, exactly.
Yeah. So all the berries, all the tangy berries, like the raspberry, is super rich in these. And these precursors are called polyphenols. There's a certain class of polyphenols. So they're like antioxidants. They're scavengers. They keep the oxidative stress away in cells. So if you're taking a lot of pomegranate or raspberries or even nuts like pecans and walnuts, which have a lot of high content of these polyphenols, and if you have the right gut microbiome, which we see only, as you were saying, only 30% to 40% people have the right gut microbiome, you could make this molecule naturally. And what we see, and I've run studies all around the world in France, Italy, US, Canada, in French and Italians and Spanish, which I'm assuming they're eating this Mediterranean diet, so they're getting exposed to a lot of these fresh, nuts and berries. You see the highest. That's where the 30-40% comes from in natural levels. In the American and the Canadians, it's like 10 to 15%. So it's even half that naturally, because not everybody is eating a bowl of nuts and berries or drinking a glass of pomegranate juice. I'm now running a study in some parts of Asia, particularly the country I come from, where I was born in India, and the incidence is even lower because growing up, everybody just gets a lot of antibiotics, So, you never give the gut microbiome a chance to, even if you're thinking you're drinking that glass of juice. So back to the test you're talking about, I invented this test several years back, and we still have that study running if folks still want to try the test, where you can actually know if your body is your gut microbiome can make that molecule naturally or not. So it's a postbiotic. A lot of us don't make it, and even if we make it in different levels. A lot of times those are not enough, and so we basically short-circuited the whole natural process and provided a calibrated nutritional supplementation strategy that allows you to get the benefits of this molecule.
So is it possible that, and it would depend, right? I mean, I'm wondering if children who are, children with a great diet who haven't had 27 different rounds of antibiotics before they're 10, which sadly is, happens a lot. But if you take a child with a healthy microbiome, they probably would naturally make a reasonable amount of Urolithin A on their own. It's just those changes that happen over time, not to mention and I think, as you said earlier, there's no doubt that the human microbiome is evolving to less diversity and generally in the wrong direction. And it's not just one thing that's driving those shifts. It's, it's the environment that we're in, it's the stressors, it's the sleep, it's the diet, it's the,
Of course.
and then with the diet wars that are going on right now, so
Mhm.
lack of diversity in the diet, I think that we're in a world where we're just not set up naturally with that diversity, and particularly the specific species you need to
Yeah.
convert. And it's eleagic. Is it eleagic acid?
The elagitanins are the polyphenols. They get converted by the gut microbiome first to ellagic acid, and then and we have tried to figure out what is these consortia of gut microbiome in the blessed people, as I call them, who make the molecule.
Blessed.
But we have come close, but I don't think it's a single bacteria that you can make, as a probiotic. It's really a consortia. We do see these people who are blessed or who are very good producers of naturally of urolithin A. They, as you were mentioning, they have a very rich and very diverse gut microbiome. I've sequenced their gut microbiome. They have a lot of Akkermansia, all the good healthy bacteria. Now, whether Akkermansia is causing that conversion, we don't know.
Yeah. Well, and Akkermansia is a good news, bad news thing, right? I mean, I shockingly didn't realize this, right? So I last year did a test. I didn't have Akkermansia. So I took a probiotic, I took polyphenols, and I fed it. And then when I was done with that run, I thought, well, I better keep taking those polyphenols. And then all of a sudden I ended up with an overgrowth of Akkermansia, which as it turns out is not a good thing.
Yeah.
So all of the, it's funny how when we dive into the microbiome and we start trying to manipulate one thing or another, we inherently create these imbalances. So anyway, back to our urolithin A story and the immune system. So that's where urolithin A comes from, you guys. And so for everybody who's wondering, well, why can't I get it from my food? You have your answer. You can go to the Timeline website and you still have that study going. So right? So people could potentially buy.
I can provide you the link in the show footnotes and
in the show notes.
Yeah.
So if anybody wants to test the microbiome and see if you're one of the blessed people that has that diversity and that combination, you get.
I'm not, and I have tried drinking 6 glasses of pomegranate juice, which, by the way, is 30 grams of sugar.
I was going to say that's a lot of sugar. It tastes good.
Well, yeah, it tastes good, but it's useless for me because my body just refuses to make it.
So your blood sugar goes up, your type 2 diabetes risk skyrockets, and there you go. And you still don't have urolithin A. All right, so let's talk a little bit about the studies that you did. Let's start with the animal models. I mean, there's a very cool one that you did with a company called True Diagnostic that a lot of people are familiar with. I mean, it's small, but really interesting. But let's talk first about the mouse studies, because the first one that I looked at that you sent me talked specifically about colorectal cancer. And is that because that's the cancer that seems to be most impacted by urolithin A, or was it just like a model that you were looking at and that just happened to be what you were studying?
Yeah. So, this is a fascinating story. A famous professor in Germany came to us several years back and said, well, I need some urolithin A. We are seeing in colorectal cancer models and in colorectal cancer patients that the immune cells, these sort of super elite T cells, CD8 T cells, they have mitochondrial issues and they can't really keep the cancer away, or we can't seek to, today in modern medicine, we have a lot of good cancer therapies as well. And a lot of these immune therapies that kind of try to revive the immune system, they're not working in this class of patients. So at the same time, we had just published our first 2019, our first human trial showing that urolithin A was able to revive the mitochondria back to good health. And so he got the compound from us, and 3 or 4 years after, he came and showed us, totally independent researcher, that, your compound is not only safe and is causing this immune rejuvenation in the colorectal cancer models, but it's actually lowering the burden and the incidence of colorectal cancer. And that made sense from 2 points. It made sense from the sort of the mitochondrial recycling effects that we were talking about. But this is a gut microbiome metabolite. This is seated in the gut microbiome, and a lot of the origins of colorectal cancer are in inflammatory bowel disease, gut microbiome dysfunction, and that ultimately lead to the sequelae of colorectal cancer. So that those data were very striking. And what he said at that time was this is having an effect not only on the global immune system, but there's a very specific effect on CD8 T cells, these sort of super patrollers. And even if we tie it to standard immunotherapies that try to rejuvenate, like when you're actually diagnosed with cancer, it's where those therapies are working better in these models. So that was the first set of experiments. In the second, another group of researchers in the US in Mount Sinai came to us. It's not published yet, but they said, well, we've been doing these studies with pomegranate juice. Again, back to the pomegranate juice in prostate cancer people. And we only see the people who are responding are those who have Urolithin A in their circulation to pomegranate juice. And that triggered an even bigger idea, which has now resulted in an ongoing cancer clinical trial with the National Cancer Institute in the US, where they actually they have taken the MitoPure Urolithin A from us, and they're independently running a trial in prostate cancer patients. So those were sort of
So these are human. This last one is a human trial.
This last one has been translated into a human trial. I think they published the pomegranate juice story showing that only the responders were the prostate cancer patients that had Urolithin A in their circulation. And so that's the translation of preclinical to clinical. There's another group very close to us in the University of Lausanne here in Switzerland that was looking at what happens post-cancer. So people who actually beat cancer, who have taken chemo and radiotherapy and now are recovering their immune system. And they found that seeding this natural compound Urolithin A in the diet of their cancer-free mice led to a better immune reseeding and lower sort of reemergence of cancer after. So those led to this clinical trial we did, and we can talk about it.
Wow. So the prostate one that's not published, I want to clarify for the audience, the prostate one that's not published yet, that's a human trial. Most of the other trials we've talked about still are kind of in most populations. Mm-hmm. They're not quite human yet, but my guess is, I would think, given what you're seeing, it would make sense to kind of maybe slide some Urolithin A to people who might.
Well, again, I think to run cancer
studies. Sorry,
those are long. Just the trial that National Cancer Institute is running, we as a small company would never be able to do it because hundreds of cancer patients across 6 sites in really top university hospitals in the U.S. What we wanted to study in the clinical trial that we just did was what's happening in a healthy population. So, quote unquote, you're healthy. What if you gave Urolithin A for a certain amount of time? What will be the effect on these immune system? What shifts that dictate immune aging?
Right. And I think one of the other things that we haven't touched on yet, but one of the things that the immune system is able to do, there was something about better antigen presentation in the papers. And so antigens is what a cell presents to the immune system so that the immune system recognizes what's happening in the cell. Do you want to talk about that a little bit? I mean, we're getting really technical here, guys.
But I'll keep it, maybe let's simplify it. So the immune system, again, it's as I said, it's like a police, it's like the army, right? So it sees a foreign invader. In this case, let's talk about a virus. The virus is seen by what is the immune system has 2 kind of levels of security. Okay, there's the police. Let's say at the first level, they see the virus, they catch it. Okay, they catch it and they chop it into, well, in terms of a cellular, they break it down to get the truth out of the invader. Now, this is what you call, these small pieces become what you're calling antigen, that are then presented by an antigen-presenting cell, which to an immunologist will say it's a dendritic cell or a macrophage cell that has the ability to engulf and eat and process these smaller, eaten apart parts of the virus to a T cell. Now, a naive T cell or a young T cell sees it, says, now I want to invade and call the whole army. And so it divides, calls all its other buddies, and they try to kill this antigen. So it remembers now. Now it's become a memory T cell. So that's how the immune system works. And when you're young and you want to prevent, in developed world, polio from not happening, people vaccinate against polio. They're giving these small
Right.
antigens in the vaccine. That's how it works.
Right. And so urolithin A is essentially helping the immune system to do this work of
To do the eating part much more efficiently. So what we saw that in this, and this has been shown before in other, let's say, cell-based systems where people had treated macrophages or dendritic cells, they find that their efficiency of breaking these viruses and presenting them to a T cell becomes about 20-30% even better. And that's what we're seeing in the randomized trial as well.
amazing. All
Yeah.
right. So, okay, so let's get to the what's it called? The Mitoimmune randomized control trial, which is, it's a tiny trial, but it's a really interesting. I think it just provides really interesting insight into the importance of this whole immune system to the aging process, or how we measure aging. So I'm going to turn it over to you and let you
Yeah.
share with the audience what happened here.
I've been doing clinical trials for 20 years. I think this is the trial I'm most proud of because it brings me back to my, not just clinical roots, but as an immunologist. And we've partnered with really the best immunologists in this study. So we partnered with the Buck Institute of Aging, the lab of Professor Eric Verdun, which is, for folks who don't know, they discovered how the immune system responds to a lot of viruses like HIV. They discovered how immune senescence happens. And then we partnered with the lab the cancer lab in Germany that discovered all these great benefits in preclinical models. So the Mitoimmune is a trial where we took 50 healthy middle-aged adults, so folks who will be in this trajectory of starting on the immune aging path, 40 to 45, starting to all the way till 65, 70. So the average age was around 52, 53 years. 25 people got a placebo. So the way clinical trials work is you take 50 people, you have a software that anonymously and randomized in a randomized way assigns somebody to a placebo, somebody to the mitopure urolithin A dosing. And so neither the investigator knows, neither the subject knows what they're taking. So this was a 1 month long trial where at the start of the trial, we took a small amount of blood from these individual participants, and we basically did what a clinician will do to study your heart health, profile, like what is your LDL level, what is your HDL level, what is your cholesterol level. So similar approach was applied to the immune system. We wanted to know how many lymphocytes were there, how many dendritic cells were there, how many T cells were there. And so today clinicians are not looking at it because I would say they don't know the importance of the immune system a lot in the early sort of the decline in immune aging. But yes, they would look at lymphocytes, for example, which is sort of the standard. So we did that, and then we send the immune cells to the US, to the lab of the Buck Institute of Aging. Now they're doing what is really, I call the futuristic version of how medicine will move, is with a tiny drop of blood. They can tell you how good the mitochondria are in your immune cells. They can tell you how good is your immune health and your immune age, basically. So they kind of, and then we partnered with a third group called True Diagnostic, which you mentioned, which has this technology to look at alterations in genes of immune cells, and we can get a sort of idea about biological age of these immune cells. So we did these at the start and end of the 1 month long intervention in these 50 folks. And when we finished the study, an independent statistician and an independent group of experts looked at the data. We unblinded the study, so now we try to see what the effect of urolithin A is versus the placebo. And so I'll summarize maybe in 3 bullet points what we see. One, we see immune rejuvenation happening, meaning now the immune system is not looking like an exhausted immune system of a 50-year-old. It's looking more like it's gone back to when it was in its youth, like 30 and in its mid 30s. So now you have more CD8 T cells, these elite forces that are ready to fight infection. Second, we see many more mitochondria, healthy mitochondria inside these immune cells. So now we see about a 20% increase in PGC1 alpha inside these immune cells. PGC1 alpha is, for those who don't know, is the gold standard biomarker that shows there's more mitochondria in your body. And third, we see is that the immune system, this inflammaging, is dampened. So these 50-year-olds, they come in with high levels of inflammaging, and that is dampened. So these are the three
Mhm.
findings, and we can talk about things that we see with True Diagnostic and others as well.
Well, I think one of the things that a lot of people in the audience are now kind of cluing into is this whole. So, first of all, that's fascinating. It's fascinating that after just 4 weeks, you're able to have that degree of impact on how the immune system looks and how it's working. Are you able to share what dose of urolithin A people were being given through the study?
Yeah, so in this study, we used a gram because we had seen better immune effects in the previous trial. So we know 500 milligram is the dose where we start seeing this mitochondrial effects and muscle effects. But we wanted to do a quick study and then see what effect was happening at 1 month time point. So we went with a gram, which is a higher
Right.
dose where we see better effects.
So, do you think that at the 500 milligram, you would get those effects? It would just take longer, or do you think you need that high dose out of the gate?
I think it will take longer, and that's what we are seeing sort of in the previous trials on muscle. We see about 2 to 4 months the effects on muscle. I think if you think about sort of, and this is an approach that I think a lot of clinicians ask me, well, I see a fatigued, inflamed patient or person. Should I do the high dose or should I do a gram or should I do the 500? And I think it's really, and that's why we invented the test even, because I think if you're naturally making the molecule at certain levels, 500 is sort of the optimal maintenance dose that you can
Yeah,
take. But for somebody like this person I talked about who's inflamed, has chronic fatigue issues, or even on the other hand, somebody like me whose body doesn't make it naturally, I would say a gram is a better way. You
yeah.
feel the benefits, you tweak your cells, have better cellular health, and then you can go down on a
I was going to say you might do like a hard hitting induction period,
yeah,
depending on the individual.
yeah,
Maybe carry a gram through, whether it's a month, 2 months, 3 months. You
yeah,
start to see things move, and you would then maybe go back down to more of a maintenance dose.
yeah.
But for True Diagnostic, those results were really interesting too, because again, like we're talking about just 4 weeks, and I believe that what I saw and what you sent me is
Yeah.
that in just 4 weeks, people saw on average a reduction of biological age by an average of 2 years.
You got it correct. So when we first showed the data, or when these professors who we were collaborating with, when Professor were done, the Buck Institute saw this data. He was astonished because he said in 4 weeks to see this impact first on the immune rejuvenation is astonishing. And the second, the only sort of intervention that is known to have such benefits is fasting, right? So in these trials that are done with the intermittent fasting, in about few months, that's what they're seeing, and they're seeing even a biological age reversal of about 2.6 years after a few months. So that's the first thing he told me. Well, this is probably the only intervention outside fasting that I've seen that is having these immune effects. So the biological age was altered. This was done on a smaller cohort of the study participants, and we are now ramping it up and doing a collaborative partnership with True Diagnostic, because I really think that that's the concept, right? If your biological age, your cellular age is healthy, if you can keep your cellular age lower, then that's what's going to help you when you're in your 60s and 70s. I mean, I see longevity as a marathon, right? So
Mhm.
Alzheimer's or heart diseases, they don't occur like this when you're 60s and 70s. They're actually seated in your 30s and 40s and 50s. And so this is what I think is the key thing in the cellular nutrition field, that you can change the health of your cellular pathways, whether it's immune cells or muscle cells. I mean, it's really, yeah, the mitochondria are key.
Yeah, no, it's phenomenal. And so So number one, it's going to be super interesting to see on the larger trials how this all plays out as well. I mean, I mean, there's no reason to think that it's going to look very different simply because you weren't picky. I mean, oh, actually, I did have a question.
Yeah,
Were
sure.
you were in this in this trial? Did you include men and women, or was it just one gender?
No, it was both genders. And if I recall the split, so this is still under review in a top journal, but I'm pretty sure it was 60-40, 60% being women and 40% being men in this
So
group.
that's really interesting, right? Because at that age, in that age window, we're talking for the most part about menopausal women,
Yeah.
and that's in that population, we're starting to understand that there's an acceleration of aging
Yeah.
at menopause or after menopause, and so how interesting is it that this could be one of the strategies that we use to offset that acceleration of aging at that stage of life. Do you and I mean, you have, I don't think you, I mean, I'm asking this out of the blue. Do you think that if we stack, us biohacking folks or
Hmm.
people in this space, we
Hmm.
love to combine things. We like to build stacks. And
Hmm.
so would you expect that combining some degree of fasting with the Urolithin A supplementation at the same time, that we could amplify those benefits?
I truly believe, actually, and there are probably many more trials that we need to
Sure.
run. I see this approach as sort of the foundation, right? So if you can improve your cellular health, now whether it's exercise or fasting, whether it's the recovery piece from after an intense exercise bout, or metabolic health after changes in metabolic health after fasting, you can really have augmented responses to those methods. And even if you're stacking other nutrients, so like if you're taking a multivitamin or you're taking CoQ10, I truly believe, and this is something we need to do in the future, that you will probably accelerate the effects of those other nutrients if your underlying cellular health is better. And that's how I really see
For
uh,
sure.
this postbiotic.
Yeah, no, and it makes sense, right? Because if the postbiotic is supporting mitochondrial health, and now we start to add CoQ10, PQQ, like some of these other elements that we know also benefit the mitochondria, we should see
Yeah.
just um, the sum being greater than the parts, as it
Yeah.
were.
And
And I think the lifestyle strategies are really interesting, right? Because people are always asking, well, what can I do
yeah.
rather than what can I take?
Mhm.
Um, and you mentioned the fasting. I believe caloric restriction is in
Yeah.
there as well.
Yeah.
Um, Things like exercise, probably contrast therapy, like cold exposure sauna, that kind of thing. These are all lifestyle strategies we can do to support our mitochondria. Things like even red light or infrared
Yeah.
light
Yeah.
therapy. But there's no doubt that to drive mitophagy, like drive that turnover also,
Mm.
like actively with the compound, is going to probably just boost those benefits to the next level.
Absolutely, 200%. And honestly, in the last year, I've received proposals uh, from different professors, different investigators. Somebody suggesting to combine Urolithin A supplementation with hyperbaric chamber therapy. Somebody suggesting to do red light therapy. Somebody suggesting, we actually did ourselves, an exercise alone versus exercise plus Urolithin A Mitopure study. And we
Yeah.
see that, in that study, for example, we don't see enough further augmentation of physical performance, but we do see the better recovery because a lot of times people who exercise a lot, they have hit a threshold of their physical performance, and you perhaps can
Mhm.
improve it further. But how fast can they recover from the soreness, from the muscle damage? So we see added elements in fasting, something that I would love to combine it with. Yeah.
Yeah. Well, I don't, I'm sure you're familiar with Walter Longo's work with the 5-day fast mimicking diet. And one of the things that struck me when I first read his book, like years ago when it first came out, is when now you've got these Prolon kits that just make it easy for people
Mhm.
to execute a 5-day FMD, which I have to say, I didn't used to be much of a fan, but if it makes it doable for people, then it's worth its weight in gold, right?
Mhm.
When he first did his studies, he was putting people on this modified Mediterranean diet, which you mentioned earlier, which and again, and I think he did those studies in Italy with people who, and I remember seeing some of the recipes of some of the foods that people ate, and pomegranate was in there.
Mhm.
And you have to wonder how much, you know, where urolithin A may have even fit in there, because now you've got a 5-day intervention that mimics fasting.
Mhm.
And it's pretty darn close to fasting. I mean, if you've ever done a 5-day FMD, it's not exactly a walk in the park. It's easier than a water fast. You're still having to exercise some discipline, but you can see in there like those little pieces of the puzzle that might feed this urolithin A train at the same time.
Mhm. Mhm. No, I couldn't agree more. I've thought a lot about it. I think combining something like the Prolon equivalent of the fasting mimicking diet or intermittent fasting. I mean, we have data in rodent models that we have not done the randomized clinical trial with the combination. But when we look at autophagy and mitophagy at a cellular level, adding urolithin A to caloric restriction augments the response even greater of the effect of caloric restriction. So we know that it, it can do that, and certainly, yeah, this is something perhaps I need to write to Walter Lungo and we talk about it.
Well, or if you could add urolithin A to the TRIM study next time,
Yeah.
like you've got all of these really interesting studies going on around biological age reversal. And
Mhm.
now that you have insight that you have a molecule in your hands that in itself
Right.
can influence that process, what happens when
Yeah.
we start to add it to other strategies that do the same thing? So
Yeah.
it becomes a very powerful tool. So talk to me a little bit about, because we talked about cancer earlier. Definitely there was a colorectal cancer
Yeah.
specifically, but this is going to, as the research moves, I'm sure you'll be looking at cancer in general, because in the studies they were talking about tumor load in general.
Yeah.
Are you seeing kind of studies coming down the pipes where there's a study on just general cancer, or
So
what are your thoughts on that?
the way I approach clinical translation is we know now that we are having this great effect at the immune level where we know that the immune system is rewired. I think the next step would be to go into an older population and show that the effect is conserved, because here we're talking about 50-year-olds that are on this trajectory. So we know that the decline is even more in the 65 to 90 population,
Mm-hmm.
90 years population. So can we take the 70, 75 age population that is, of course, under the insult of chronic ailments, under the insult of a lot of polymedication, and can we show that we have reversed the same effect in an older population, and that they have, less infections, or they have a
Yeah.
better response to a pneumococcal vaccine that a lot of them they get, but only, you'll be surprised, only 10% respond to the
Mm-hmm.
vaccine, yet everybody is getting it. So that's one route I see. The second route I see is really partnering and doing these hundreds and thousands of folks, looking at different ages, different genders, different ethnicity on this immune aging concept. So can we rewire our immune age to be younger? And then the cancer piece is I see that as two strategies. One is the post cancer strategy, which makes a lot of sense, because these folks that are recovering or have beaten cancer, they have cachexia. They have what we call muscle wasting. They have their immune system is basically practically
Yeah.
deficient. They're almost like walking around with no immune system. And so that is one post cancer is where we are planning to run a trial to show that the receding of the immune system after ovarian cancer is even better. So that's a trial we've got one a grant and we're trying to do. And then there's this piece where we are partnering with the National Cancer Institute on prostate cancer, for example. And really, I think the tricky piece for a nutritional supplement to go and show that you've reduced the cancer incidence is that the regulatory bodies will see it as a drug trial and not a supplement trial. But the approach should be to combine it with standard of care, which is these immunotherapies. So this is a trial that I'm discussing right now. Can we augment the response of a lot of these immune therapies that a lot of folks can't respond to because the immune cells are exhausted? And so can we improve that?
Yeah, it's crazy. Like what you just mentioned, it's kind of damned if you do, damned if you don't. Like
Yeah.
it's kind of tragic. And because we often see people who survive one cancer only down the road to develop a secondary cancer because of the hit. I mean, number one, because of the damage done to their cells by the very therapies that kill the first cancer, but also because of the hit that the immune system takes in that process. So how amazing would it be to have a compound that can assist and work with the body to kind of help to bolster that system back up again?
And that's where, as doctors, I think our modern medicine is failing us a little bit, because it's not telling you what to do in your 40s and 50s, so you have a better shot at the goal to keep cancer when you're 60s and 70. And I think a lot of these adjunct modalities of intervention, nutritional therapies, or natural compounds like Urolithin A or even CoQ10, these can help augment your immune cells to fight better. I think that's the way to think about it.
Yeah, no, that's fantastic. This is so exciting. This is just really exciting. So now we had taught not to steal the thunder from immune, but I mean, listen, if we can get our immune systems and keep them running like they're young when we're old, then we get younger as we get older. So there's no doubt there. But when we spoke last time, you did talk, and I think they were studies that were being run in other labs by other people around neurodegenerative or cognitive health, because the brain also, of course, massive repository of mitochondria. The heart is like, it's a whole other muscle. Are you seeing other, like, is our next podcast going to be talking about one of those, or?
Clinical studies take time. So we are embarking on this really fascinating study with a group in Norway that has been actually studying this cohort of people that exist in the Norwegian healthy population. They're all in their mid 50s, but they have sleep issues, and they have this they call as REM sleep issues. But what is fascinating is that as they study them, all of these guys, about 95% of the time, they convert 10, 20, 15, 20 years down the road into Alzheimer's or other neurodegenerative issues. So sleep problems, these sleep disorders, and they've now actually seen in these quote unquote healthy people who have sleep issues that their mitochondria are very dysfunctional in their brain, and the bioenergetics of the brain is not right. And so we're now just about to kick off a new studies, trying again to intervene early rather than when the damage is all done. Can we intervene on brain metabolism and the mitochondrial health of the brain cells, and can we improve sort of this trajectory towards neurodegeneration? So that's one study we are doing. On the cardiac front, I think there's some very exciting data that will come out at the animal model level, where we have looked at cohorts of folks who get MI or atherosclerosis or any chronic vascular sort of disease. And when we see the signature that is consistent across these cardiovascular diseases is mitochondrial dysfunction. And so now we are looking in models of heart failure or even heart aging to see if Urolithin A MitoPure can reverse a lot of these effects. And that's what we are seeing. So wait for it to be published, and then we can talk about a new clinical trial.
Fantastic. Well, and just to circle back to our opening premise, which is fundamentally that Urolithin A doesn't choose. It's introduced into the system, and it's going to affect mitochondrial health, function, and turnover globally. And so all we're doing here is kind of opening little doors into different systems to see, here's what's happening in the skeletal muscle system, and here's what's happening in the immune system. And as you move down the road, you're just going to keep opening those doors. So I think for people listening, the good news is that if you can give yourself access to urolithin A as a nutrient, you can globally positively impact mitochondria, which, as we ad nauseum keep talking about these days, if you can get the mitochondria up and running and keep them there, then a lot of things go right in the body.
Yeah, research is a journey, and I was taught that by my professor who trained me from a doctor to a physician scientist, and he looked like Santa Claus, and he was actually in his behavior like Santa Claus, and he would tell me, Anurag, research is two words, reinsert. You have to keep going back again and again. And
oh my
so
God!
I realized that now after 15 years of studying this molecule, that it is exactly like this. We are unpacking new data every year. As you said, we'll figure it out more next year and the years ahead. But it's really fascinating how our microbiomes have shifted. Our ancestors were making the right gut microbiome. They were eating fresh foods and nuts, and all of them probably were making it. And somehow we have evolved to a point where less than a half of us make this molecule. So it's fascinating. So thanks for having me back.
It's been a pleasure. It's always great speaking with you. And folks, I'm going to include links to some of those studies in the show notes so that those of you who want to dive in can do so. And we will have a special code for listeners of the podcast, which you probably heard in the intro and will also be in the show notes. But if you want more information, you can go to timelinenutrition.com. So for more information, timelinenutrition.com. And Dr. Singh, thank you so much for being here today. It's always a pleasure to chat with you.
Pleasure to always chat with you. Thank you for having me.
My pleasure. Okay, folks. So thank you so much. For listeners of the podcast, we have a special deal for you. All you have to do is go to timelinenutrition.com/NAT10 and or use code NAT10. And the nice thing about this website just is that there's so much information there. There's lots of research, lots of resources, and it's a great place to hang out and geek out on mitochondria and urolithin A. Thank you so much.